Swayam Prabha. Digital India. Educated India.
Hello, welcome to the new discussion, and this is the last part of pre-processing of spatial data sets, and here we are again going to take further discussion on this image merging and image fusion in a little different way. As I said that in earlier discussion that instead of two images of different spatial resolution, we can take two images of the same resolution but different dates. So, one variable we can change and can remain within that color space and can create new products. Here what we are going to do, we are going to create a new product using image and a scanned map, and you would see the advantage. This is about the Dal Lake, which is in Srinagar, Kashmir, and we were working for a project. I will tell you a little story about this, that how this technique was developed. So, when that project we wanted to restore the this Dal Lake, and one more small lake is there, that is called Nagin Lake. So, we wanted to restore the, this is Nagin Lake. So, we wanted to restore the the shape and quality, water quality of these two lakes. Now, challenge was there that we wanted to have a very authentic record of the shape of that lake through some reliable maps, and luckily we got a map of 1968 of Survey of India, which we can which we considered, and still we feel that their products are really very accurate and genuine. So, taking that 1968 as a base year, now we wanted to create a change map in which we can show that what is the today's condition and what was the in 1968. And for today's, of course, you can resort to the satellite images, and whereas for 1968, as you know that there were no satellite images, only in 1972 onward we started getting Landsat data and some other satellite data. So, at that time though there were no satellites, so we resorted to this large scale 12,000 1:12,000 scale map, which had the authentic record of the shape of this Dal Lake. So, in order to detect the changes which was occurred between 1968 and in 1998, we took this satellite image of IRS list 3, and this is band 3 image, and then using that again color space concept or the pseudo color transform image concept, we prepared a new product which had the map as well as your image. So, map belongs to 1968 and the image belongs to 1998. Now, 30 years time difference and change detection map or image was created here, which very clearly shows that which are the areas which have been encroached, or which are the areas where the shape of the lake has distorted because of human activities or some maybe the natural one also. So, there are few points which one can interpret very easily, that the northern part of this Dal Lake and northern part of this Dal Lake, as you can see here, that lot of red areas are appearing. These red areas are showing the changes which has occurred between 1968 to 1998 in terms of growth of vegetation. Because as you know that in this Dal Lake, it is a quite shallow lake. The average depth is about 1.1 meter. So, it is a very shallow lake, but it is a huge lake, huge water body, and there are a lot of people which grow vegetables on floating farms, and that means they have created lot of these growth of vegetation or either on the floating forms like this in the northern part, and this area is full of these houseboats which is near this boulevard or the gate and Dal Gate. So here you also see that there is a lot of growth of vegetation. Further, if you see 1968 this map, you would see that there were connection between Dal Lake and Nagin Lake, and there were connections, and these sikaras or small boats used to go from one lake to another lake. But in this image you would find that all those channels have been blocked because of growth of vegetation. So if we want to see the changes which has occurred in last those 30 years, and where two things, where the changes has occurred and how much changes have occurred, that can be detected through this technique, pseudo color transformation technique, and that comes under this whole discussion, that is image merging or image fusion. I will show you some blow up of these parts, that this is of course black and white of that scanned map, and here this is the area where things have been encroached, and as you can see very clearly all these red areas are showing growth of vegetation. And see this channel has also been blocked, these channels have also been blocked. These channels were allowing passage to connect to the Nagin Lake and other parts of this area. So all those were blocked because of growth of vegetation, no care was taken, and you know the health of the lake also deteriorates because of it is going away from its natural existence. So for in order to restore that thing, we decided that we can go back to 1968 because that is the authentic data available to us. One more, for the northern part, as you can see that in the 1968 image there were hardly any growth of vegetation in this part, but in 1998 after 30 years you see large growth. This is infrared channel, and infrared channel is showing high reflectance value for green vegetation, and when we bring in the PCT we can clearly demarcate which are the areas which have been encroached or which are the areas which have been blocked because of growth of vegetation. And therefore of course the shape of Dal Lake has also got changed in those 30 years. Now if I want to do the comparison between 1998 to say 2020, no issue. Again I can employ the latest images, I can use the old images, I can create a pseudo color transform image, and again can see that what has happened between these two dates. The other advantages of the pseudo color transform image, that whenever we want to employ different satellite images, map or images together, and for change detection, this is perhaps the best technique, highly reliable, because no bias will be there. Only requirement is image to image registration and then the pseudo color transformation. That means we are playing within color space. I will give you one more example, a little different example, where one completely synthetic image has been used, which is because this image is suffering from a phenomena which is called false topographic perception phenomena, and this happens in all satellite images of all parts of the earth, moon and Mars. This is what it has been checked of hilly terrain. So these image, like this image on the left side, is suffering from that false topographic perception phenomena, FTPP. Now we wanted to remove that FTPP phenomena. So what we did, we split this RGB or FCC image into three components, IHS. Again you are playing with the within the color space. So first RGB image using 3 bands of the sensor or the satellite bands were added to make this called color composite. Now that color composite has been split into three components: intensity, hue and saturation. Now what we did, we removed or we got rid of this intensity image, because as you can see it is suffering from FTPP, and the rest, these two images of IHS transform, hue and saturation continues in our processing, and this image, the intensity image, was replaced by a simulated image which has been created using digital elevation model, and this image is called shadow relief model, which as per our requirements we can create our own illumination source rather than depending on natural illumination source, which is sun. So normally in the satellite images, when the images are acquired in morning hours, the sun is in the southeast quadrant. But in this image, what we did, we created this simulated image using sun illumination direction is from northwest quadrant, and by which we could get rid of FTPP, that is false topographic perception phenomena. So now this image, which is of course becomes intensity image, is not suffering from FTPP. It is not suffering from FTPP. And these two images, hue and saturation image, continues in our this composition. And what we did, again IHS to RGB, and when we do this backward transformation as done here, if you compare this input image which is here and this is output image, you would notice that this river, Bhagirathi river, which was as it was visible that it is flowing on the ridge, which is not possible because it was happening due to FTPP, is no more suffering from FTPP, and that river has gone into the valley, and now we are getting correct perception. So a big phenomena which was affecting our image interpretation, image analysis, has been removed using again a image merging technique. And here, instead of going for different dates or instead of going for different spatial resolution images, we brought a new concept here, a shadow relief model that was derived from a digital elevation model, and that digital elevation model was created using contours available in the Survey of India topo sheets. And by nowadays lot of digital elevation models at high spatial resolutions are also available, which have been generated using different satellite image processing techniques. Those can also be employed, and then this FTPP can be removed very successfully. So in all these examples in the previous lecture or here, I am showing all kind of possibilities with playing within color space and creating new and very useful products. Otherwise, individually they cannot be, these images or maps cannot be those useful, or interpretation becomes very, very difficult. So if all the changes by some means, if you can bring within one image, and then color will depict, you can do the masking and you can bring all changes very nicely. Here we exploited the same concept of color space, created a new product and got rid of false topographic perception phenomena. So just in large part I will show this image is suffering from FTPP. This is having FTPP, as you can see that here the Bhagirathi, which is tributary of Ganges, seems to be flowing on the ridge, which is not possible at all geomorphologically or topographically. But when we bring this if you notice here the sun azimuth, that means it is somewhere in the southeast quadrant, and in this simulated image, which becomes our intensity image, sun is in the northwest quadrant. You can see, notice this these angles, that here it is 163. If you add 180 degree, that means you are forcing sun to illuminate in this one, and since this is simulated image. So when we combine these two, we get a new product in which river is flowing in the valley, giving the correct perception. That means we got rid of FTPP and we got a new product, which is very useful, and reliable interpretations image analysis can be performed on this image very easily. Otherwise, on the original image which is suffering from FTPP, if attempts are made, people will make wrong interpretations. So, in order to avoid, again we have used this image merging or image fusing technique. Similarly, one more example is here, that this is a input image, this is digital elevation model, and now this digital elevation model has been created using opposite sun azimuth angle, and then you get a new product something like that. So, this is FTPP corrected image. Nowadays, you do not have to create your own digital elevation model. You can employ already available digital elevation models and can get rid of FTPP using this image merging or image fusion technique. All three images together, this is suffering from FTPP, this one, the leftmost image, the center image is a shaded relief model which was created using digital elevation model, and this is FTPP corrected image where river, again this is Bhagirathi river, is flowing in the valley, which is giving us a correct perception. So, we made certain publications based on our work, like here this is I showed the example of IRS and the pen sharpen, the first example in the previous lecture, and other places. Now, there were one more topic after this image merging image fusion is edge matching. So, very briefly I will touch this point, because it will depend basically how best two data sets are available to, what is their quality, or and time difference is minimum. If suppose I am having two Survey of India topo sheets, one belongs to say 70s, one belongs to the say 2020. Now, there might be a difference at the edges which I will notice significantly because of maybe little different projection, map projections have been used, or changes which has occurred in the field. So, this may, suppose this image belongs to 1990, this image belongs to 2010, now I am having 20 years time difference. So, if this has been surveyed in 2010 and I am went edge to edge, I am trying to match, there will be mismatch something like here or something like here, or even for polyline something like here. So, this is a kind of surgical operation which one has to really do it manually. There is no automatic methods, no software has ever developed like that. So, very manually when you vectorized or digitized the data, at that time care is taken so that you continue with this one like this, you continue with this one like this, and also like this. So, manually edge matching process has to be done or achieved. And similarly, I am showing one more example here, that sometimes you may get an artifact, a polygon like this. Now, it has to be removed because while checking it was found that this is not required really, this is an artifact. So, how you would do it? Again this has to be done manually, because system does not know that which polygon is the genuine one and which one is the artifact or due to error. So, again this has to be removed, as in the right image it has been done. So, first the edges will be adjusted to match the edges of the this polygon on the right side, and then gap is removed successfully. So, this way the edge matching can be done very successfully. However, in most of the cases it will be done manually, there is no automatic method. So, depending on the problem, when you are doing edge matching, whether two topo sheets or within one map, there might be edge matching with the polygons, and but in case of two adjacent topo sheets, there may be edge matching required for polygons or merging two polygons of two different topo sheets into one, and polyline and other such features. So, every such operations like related with edge matching has to be done manually. So, this brings to the end of this discussion about the pre-processing of spatial data sets. So, we have now completed all three parts of this pre-processing. Thank you very much.